Swayam Prabha. Digital India. Educated India.
Okay, it's really exciting being here. I really enjoy these talks to people who are just coming to your 12th standard like you. One announcement I have to make. If I like these sessions to be very interactive. Okay, it is not a lecture. It is actually a discussion. Okay, so let us all take it to heart. I want you to ask questions. Okay, but the announcement is when you ask your question, please raise your hand. Switch on the mic and answer, because only then the recording will be good and other people can use it later. Okay, deal? Everybody? Okay. Yes, and the part about it being very interactive is very important. Okay, it's not just something that every teacher will tell you or anything like that. I really want people, and the way you have to listen to this or any talk, this is a general suggestion, is whenever I say something, you should be a little bit suspicious of what I'm saying. Is he trying to sell me a bridge later after this? Is there some nice trinket he's going to say 500 rupees? So you should be a little bit suspicious about whatever I say. In that way, what will happen is you will listen to stuff much better. You will really understand stuff. If you just sat and just let all whatever I'm saying just flow through you, it will appear as if you understood stuff. But your ego will not come into play. If you say, this is suspicious, this is doesn't sound right, that means your ego is coming into play and say, hey, I have to say something wrong about that. Then you will listen better, right? I'm serious about it. This is a thing that I try to go to talks which are not related to my area. Just sit, listen to them. But if I just sat and listened to them, especially in the afternoon after I had a nice tea, I'll start nodding off, right? So to prevent that, what I do is I'll try to say, this slide sounds suspiciously wrong. Okay, and then if I have to say why it's wrong. If I just say it's wrong, it's not good enough. It doesn't satisfy my ego. I have to say it's wrong because the moment I start thinking and I start engaging my facility like that, thinking faculty like that, I'll be able to remember the stuff, understand it much better than if I just let that person just weave a nice story around what they are saying, right? So, in this context also, let this 3 hours be very nice, informal, very interactive. I want you all to raise your hand. So, who's putting up your hand and saying whatever you said so far is bullshit? What? You didn't take my thing to... Huh? So, okay, what did I say wrong? Okay, your suspicious is good. I'm glad you took it up, but you should be suspicious about why I said suspicious also, right? I'm getting meta here, right? So anybody wants to say, no, you're wrong. We should not listen like that. We should listen the other way around, or we should listen something in a different fashion. Anybody? Just, be a contrarian. You will be helping out yourself, your friends, all, and me, definitely. Be a contrarian. Very good, excellent. What do you mean by that?
Try it out for the lecture. If it works, it works. If it doesn't work, it doesn't work.
Okay, so you're just willing to suspend. You're just saying, okay, here's somebody who's coming and saying something. Let me try out what he's saying and see if it works. Okay, fair enough. So like that, I really want all of you to take my suggestion to heart. And in the middle, okay, every once in 15 minutes or so, arbitrarily, one of you should stand up, put your hand up and say, sir, what you just now said is bullshit. Okay, use only those sentences. Okay. No, because see, what happens is, lots of times, we are so enamored by authority. Oh, there's a prof here, he did his PhD from MIT, did BTech here. No, it's okay. I can be as wrong as you can. And in fact, I'll tell you, the more basic questions that I've been asked in my class, it has gotten me to understand stuff much better over the years. Okay, when I was sitting in my class and listening, I was just, everything was flowing over me and I thought I understood stuff, right? Only when I went and said something to somebody and the student said, this doesn't sound right, that's when it shook me out of my complacency. Yeah. No, no, I'm fine. Thank you. I just thought while I was setting it up, I'll have. No, no, I'm fine. Totally fine. So that's fine. So, so this is. So please do take that up. So in the 3 hours that I signed up to have interaction with you, I wanted to convey a few points. Okay. First, the fact that even I'm an engineer. Okay, but we still use our maths, physics, chemistry as much as you are doing right now. Okay, we do have to do that, and I want to explain why we will use it, and all the stuff, the fundamentals that you're learning right now in the 11th and 12th, how valuable it is. I do want to convey to you. Okay, I'll convey to you in the context of what I have some slides on something called innovative design. Okay, because I am from the Department of Engineering Design, I'll spend a minute explaining what we do. Okay, and hopefully I'll be able to convey to you what this engineering design is all about, and so on. Okay, and then eventually I will hopefully in the afternoon talks we'll go a little bit more into mechanical behavior of materials, which is a key understanding. Some key understandings are required in order for us to be able to do some good designs. Okay, so that's my area, core area. So you can see that I try to come up with a variation of Shakespeare's To Be or Not to Be and called it To Break or Not to Break. Essentially, it's a mechanical problem, mechanics problem. So hopefully, it will be very connected with what you already have learned a little bit in mechanics. And I'm telling you that mechanics that you will learn right now, 11th and 12th, is going to stand you in good stead whatever you do tomorrow. So please pay attention. So's your maths, so's your chemistry and biology and so on. Okay. Okay. So let me just begin with a little bit of an introduction about my own department. I am in the Department of Engineering Design. Okay. So what does that? What do you think we do? How do you think we waste our time? Huh? Okay, drawing. Good. No, there's no right answer or wrong answer. Everything is awesome. No, in fact, he's probably hit it on the head much more than saying drawing. So, okay, that could be one possibility. What else? Come on, let's throw out stuff. By the way, we are supposed to put up your hand, press the thing. Oh my God, I'm having trouble here. You put up your hand, press the thing, and say what you want.
Design the most optimized way to make something.
Design the most optimized way to make something. Good. These are all parts of a sentence. I'd like to keep them all in mind and see what they mean. It's okay. So design the most optimized way to make something. Very good. I think it's actually a very nice answer. Anybody else? We'll have a couple of more.
Imagine creative solutions.
Imagine creative solutions. Is that what you said? Excellent. Imagine creative solutions. Very nice. Anybody else? One last one. Okay. Yes.
Calibrating precision.
Sorry?
Calibrating precision in what you design.
Calibrating.
Precision in what you design.
Calibrating precision in what you design. Okay. Yes.
A lot of calculations.
A lot of calculations. Drawing and calculations both come from you. Okay. Yeah, sure. Go ahead.
Running simulations on a computer about
running simulations on a computer. Okay. Okay. Any others? Hey, yeah.
Innovations that make our lives easier.
Innovations that make our lives easier. Okay. Good. So I'd like to just classify the kind of answers you all gave. Okay. Some of your answers were about doing. You said drawing, you said running simulations, so on. And other things were about imagining creative solutions. And then what was yours? Precision. Okay. So these were the kinds of answers which are mostly about doing and maybe a little bit about thinking or something like that. Okay. So, good, but actually, I would say, I'll take a slight detour, okay, and say Supposing some of you may want to be doctors, I don't know, maybe. Why do you want to be a doctor? Anybody wants to be a doctor? Okay, so why would you want to be a doctor?
I have no.
Click on, you clicked on?
I don't have a direct answer, but I think I'm interested in that sort of field. Like,
Okay.
I think it just makes me feel satisfied with what I'm doing, sort of.
But what aspect would make you satisfied?
Like just helping out someone. In a
Helping people. Okay, very good, very good. Okay, that is helping out people. Any others?
The humanitarian aspect.
The humanitarian aspects, which is also again helping out people. So, this is one very interesting thing. So, when you ask anybody, like whenever they are, why do you want to be a doctor? You'll say, I want to help people out. Right? Now, I'll ask the same question. Anybody wants to be an engineer? Okay, one of you. Why would you want to be an engineer? Why would you want to be an engineer?
Well, I'm interested in computer science engineering because I like optimizing problems. I like finding the fastest solution to something.
You like finding faster solution. Anybody else?
I want to be aerospace engineer or aeronautics engineer because like I'd like to look at something and say I built that. It runs because of me or something.
Okay, good. I would like to build that. It has not fallen out of the sky because of me. Okay, good, good. Very nice. Excellent. How about you?
To try to make things which have been only in fiction as of now.
To try to really come up with the next generation of things. In fact, actually, when I asked the previous question about what you think engineering design department does, somebody said, you know, build stuff also. They also said that. Okay. So, actually, here is a crucial difference that we don't notice. When I asked why somebody would want to be a doctor, you said you want to help society. You want to help humanitarian stuff. Okay. When I asked about why you want to be an engineer, you said like, I want to build stuff which is very cool. Correct? Actually, that's not correct. An engineer is also self-serving the society. Really speaking, we want to build stuff that will help people out in whatever way. Reach, meet their family members faster at a lesser cost, right? Or talk to family members across distances, or better diagnostic devices in medical care. It's all for the society. Okay, so as an engineering design department, we are also, as any engineering department, at the end of the day, we are also interfacing with society. We have to find out why we are doing what we are doing in terms of helping out people. Okay, so that's a very interesting and important aspect that we do not keep in mind, but it does play a very important role if you really want to be a good engineer. The reason I'll tell you that, and here the difference between, say, a doctor and engineer is, you know who you're helping out in a very immediate sense. As a doctor, you really know who your customer is. It's the particular person that you're trying to treat. In an engineer, it's a little bit more vaguer or a little bit more maybe removed from what we are doing. That is the reason for our confusion, but we should never ever forget that as an engineer also, we are in the business of helping out society. In other words, if you just gave me a ton of resources, like infinite money, infinite supply of raw material, so on, I'll be able to solve any problem, really speaking. But that's not how it is. The customer will have only a finite resources. They'll have a finite set of requirements. And for us to determine what they are, find out what they are, and then solve a problem based on that is what an engineer is setting out to do. Okay? So, Just to summarize what we have discussed so far. So in the engineering design department, the idea is to try to train the students, particularly in the mechanical and electrical combined, so-called mechatronics, using those sort of principles to come up with solutions and to train people to come up with solutions that will help the society in a different way. For give you an idea, like our department, the most famous startup from our department is Ather, the electric vehicle scooter. Those two guys were from our department. Okay, so just a brief introduction about. That said, all departments. I was in mechanical engineering here several years ago. Okay, when the dinosaurs were still roaming the earth, I did my BTech here. That time also, I was in engineering design. We were also supposed to do design, but that emphasis was not so explicit. So we were doing so-called engineering science. So that means we are understanding the science principles and trying to apply them to engineering and so on. Here in the engineering design department, we are trying to go a little bit closer to the applications of what a customer or what the society would want. Okay. So today's talk, as I mentioned to you, wanted to give you a brief background about this, and in the process, I wanted to talk about show some slides on what is called innovative design. Okay, and I think these are broad principles that can be used in any situation that you do. So that's why I like giving this talk, those particular set of slides. So I will first present that, and then in the afternoon we will discuss. We'll all together discover, some fundamental physical principles that go into, how materials behave, how we try to understand how materials behave, and eventually how they fail and so on. So breaking is the failure of materials is what I'll be focusing on. Okay. Okay. So let's while that's being set up, let's start with some. Let's start with some thought process on how to do what we mean by design. Okay. So as I mentioned to you, an engineer is also trying to serve society. In other words, come up with a solution that satisfies a need, a societal need. Okay. So now let us try our hand at it ourselves. Let us all try our hand at it. So this design need not be, in engineering, if you use engineering principles, it will be engineering design, but you can do design in other situations also. So let us all think of a situation where we need to, okay. So how would you go about it? How would you plan everything? That's also a design problem. Why? Who's the customer in such a case first? Ourselves. So if you're going with your family, for example, dad, mom, like brother or sister, you, okay, maybe 3, 4, 5 of you will. What could be potential requirements? What could be constraints on the vacation? Budget, certainly, and all engineers will always first talk about budget. So you're very good, excellent. Time, exactly, and then resources like what? Tickets and visas. Okay, so those are saying, but what is it that you want? Like, let us say those things are done, the things that can be done like that. Let's say you can get it done. What is it that you will want? What will be the constraints? Sorry? Itinerary, places to see. Fun. So the concept of fun, for example, will be different for different people. Some people might want to go for some natural sightseeing, want to see that. Some people would love to watch some historical places, museums, and so on, right? Some people would like to go to the beach and just run around all day in the hot sun, right? Or some people will want something else, like nature, hiking trails or whatever. So you can clearly see that even in this sort of design problem, there will be several constraints, right? and you have to finally come up with somebody already said that, come up with an optimal solution, like optimal solution for that. That's nothing. That's exactly what we would do day in and day out in a design department. Only thing is, the topic will be, the constraints will be based on some engineering requirements and so on. Understood? So it's exactly like how we do it. So supposing I ask you to come up with a very innovative vacation plan. So not only you have to do a vacation plan, you have a budget, you have a certain amount of time, 5 days, and budget of some X rupees. You should not just come up with a vacation plan. You should come up with an innovative vacation plan. Okay, so that's how usually we are, like, somebody will come and say, we're going to build a innovative lawnmower, innovative mouse trap. Like that. So nowadays it's not just enough to do a good mouse trap, you have to do, So what does that mean is what I'm going to try to discuss in the next few minutes. Okay. Again, any questions so far?
I was reluctant, but I just want to say it. Sir, we already have tour guides to do this work for us.
Correct.
So why would we bother to do this travel particular example that you've given? Why would we want to do it? We could just tell them to make it innovative for us.
Correct. So, okay, very good. So, very good question. So, in this case, why would we want to plan, and why not just say, make it innovative? Okay, that is also part of the plan. It's also one of the solution processes. Okay, hand over the job to somebody else. But the point is, you still have to be able to explain what are the constraints, and everyone will have their own constraint. If it's the same constraint for everybody, then the problem is solved. But usually, a lot of times you come up with some unique set of constraints, and because of that, your problem solution will be unique, and because of that, maybe that will be the solution the whole world is also looking for. That's how it works. Good. So yes.
When you say innovative design, does it have to be better than the original product, or is it just different?
Excellent question. So the question is, when I say innovative design, does it have to be better, or does it just have to be different, is the question. So how many think it should be better? Okay. How many think it should just be different? Only few. So by democracy you lose. Democracy, the better, different. So, but no. So to answer your question, I would say the question itself is not very well framed, because what is this concept of better is what we have to actually find out.
I just meant it's more efficiently designed. It does its job better. So, for example, your mousetrap example. If a mousetrap was innovative, would it catch mice better? Would it just do the same job in a quirky way?
Excellent. So that's exactly the question that we have to find out the answer to, and that's what I'm going to actually talk about. Okay. So if I gave you an example, build a better washing machine. What does it, instead of 27 clothes, will it wash 28 clothes? Instead of 37 minutes, will wash in 35 minutes? What is it? So what is that is what we'll be looking at, and we'll talk about it. Okay. So we'll come to that. Actually, it's one of the key takeaways. I hope at the end of this you will be able to understand it. Okay. So first, all of you, I'm presuming, will understand these definitions easily enough. A scientist is one who just comes up with explanations of how things work. Okay. So these are explanations, and so as a scientist, how will an explanation of how things work, how will it satisfy you? So in other words, supposing I came up with an explanation, let's do everything I say, I want to, like whether or not you say it's bogus, I myself in my mind thinking, oh, did what I just say, is it bogus or is it right? Okay. So let's examine that. I said that scientists creates explanations of how things work. So let's do an example of that. Some time ago, I used to go to my office by bus every morning. Okay. So this is actually when I was in Singapore, actually, this was many years ago. I was used to take the bus. So the way it used to be is like I have to get down from my apartment complex, go cross the road, and there will be buses that go to my university. Okay. I used to notice something very peculiar. So sometimes, some days when I just woke up and I look at the alarm, just after I wake up, a few seconds later, the alarm will turn from 5:59 to 6 a.m. and then the alarm will ring. And then I noticed that those days when I'm going to my office at 8:15 or 8:30 or so, when I come to this side of the road, in Singapore you can't just cross whenever you want. You have to wait for the green signal for even crossing, right? Yeah, I used to wait on this side, and the buses that I have to take, 3 buses will come all at one time. I'll be waiting here, that signal will turn green, all 3 buses will go. I know I have to wait 45 minutes for the next bus. It used to be very irritating. And I noticed that this used to happen whenever this happened, this alarm, just before I woke up, before the alarm, this used to know, I just kept observing, it happened several times. What do you think could be an explanation of this? Sorry? So one example, waking up late. So then what is the other days, what was I doing the other days could be earlier. So it could be that, was I waking up earlier the other days, this day, but I put my alarm at 6 o'clock, presumably means that time is good enough for me to go to an office on time. Okay, so let's keep it. This is one explanation. So I want to see create explanation of how nature works and how we'll be satisfied with those explanations is what we are trying to examine. Yeah, switch on the mic.
You're anxious about missing the bus and then waiting.
So on such days, you think I'm maybe a bit anxious about missing the bus. Good. So all possibilities let us put. Yeah, go ahead.
The signal might have turned on the right time. You could have just missed the signal at the wrong time. So
correct. But how does that correlate with this other observation of this alarm clock changing at 5:15? That's the point we're trying to come up with an explanation. Yes.
Because you wake up before the alarm, you might have felt that you got up early, so you weren't as urgent.
Good. So a lot of people are nodding. Even I also thought of that. So a lot of people are thinking that just because I woke up late, it might actually be slower the whole time when I'm getting ready, right? Yes, one
coincidence.
Sorry?
Coincidence.
Coincidence. He's saying it's a coincidence. Okay, let's not rule it out.
Maybe the alarm there's some random delay to it. So sometimes it goes ahead a little bit, sometimes it goes behind a little bit.
Okay.
Time. It's not an accurate alarm.
It may not be, alarm itself may be problematic. Very good, excellent, very good. Yes?
So you said you kept the alarm every day at like 6 a.m., right?
Mm-hmm.
So maybe the buses were late themselves, or they came early on some days. Alarm, it functions properly, right? So
alarm, yeah.
The human factor of the buses.
The human factor of the buses.
You also are reaching there, that's also there.
Okay, possibility.
So maybe you snooze the alarm and you woke up late on those days, and like you
could have
woke up
snoozed the
early.
alarm and woke up later on that days, and because of that, somehow I'm missing the bus. Okay.
I have a question. My question is, how often has this happened?
How often has it happened? Good. I have to come up with a real number for that. Okay. And so, that's a good point. So this is part of the solution which I'm trying to, the whole discussion, the thought process I'm having you. This question is also part of that. The question about coincidence and the question about this. Okay. So first, we have to spend a minute actually collecting data. Yes, one point, please.
There's a human tendency to observe things if we think those happen. It might be that on other days as well, you might miss the bus, but only on the days you miss the bus and you see those, you think it happens, but it might not be the case. So there's no as correlation. Just that human tendency to observe it more if it happens.
Exactly. Very good. Very good. So excellent. I'm really happy to with the kind of interactions that we are having. So this is the point I wanted to really emphasize to everybody. Okay. First, we have to rule out coincidence and collect data. Okay, and make sure that we do not have a preconceived bias to the data. This is actually there's a word for this. Sorry, not tunnel vision. Anyway, it's just slipping my mind. Yeah.
I think it's called confirmation bias.
Confirmation. Thank you very much. It's called confirmation bias. Okay. So when you have explanation already in your mind, then you will start looking for data that will support that explanation. So if the few suspicious people who were there in the room said, "Are you sure you have enough data? Are you sure it's not just a coincidence?" It turns out that all of us should really be aware of a possibility of a confirmation. So in other words, I might have 3 times it might happen, and it did happen 3 times where I just woke up and then 5:59 turned 6 o'clock and I did miss the bus. But there were times when that same thing happened, I did not miss the bus, but I did not keep the data in mind. Conversely, there were days when that did not happen. I just went to the bus stop and I saw 3 buses going by and I just like, damn it, waste of 45 minutes, right? So the reason I'm saying this is a part of the scientific process. Please keep it in mind, and this is all that excitement of science. So tomorrow, if all of you, like many of you, take up science or engineering or whatever, so you will be going through these processes and making sure you understand what's going on. Right? So the way we try to avoid that is to try to be systematic, to try to explain it to a third party. The moment I start explaining to even all of you, immediately you started poking holes in what I said. Right? So like that. So in other words, we make sure we create explanations of what's happening, but with the caveat, with the warning that, hey, make sure you collected the right amount of data. Make sure that you're just not so excited about your explanation that you're going to start collecting data for that, and so on. Okay. So in fact, like a little bit of, if you go to the history of science also, there have been many instances where, especially, we think about the Greek astronomical thing, right? Actually, what happened was, somehow the Greeks were so enamored by models. They loved these ideal models. Plato came up with these ideal solids that should be between planets. Because of that, they were so caught up with the model that when the data was actually not matching with it, they discarded the data and kept the model. The first instances of fraud started with that sort of extreme attachment to models. Okay? So it's a very interesting observation, something to keep in mind. So it's lots of times, as scientists, we get so attached to the explanation that we are not keen on trying to. So this is one point I was just trying to say, and just slipped my mind. Yeah. So, and sometimes, and even if you come up with a model of something, an explanation, which is nothing but a model, okay? What is the role of the model? What do you think? Why do we need these explanations? Why do we need these models?
To try to predict what will happen.
To try to predict something about what will happen. Why do we, so the question is, why do we need models? Why do we need these explanations?
We might be able to understand it without a model, but then to explain the same reasoning to some other person, a model is much useful.
to try to convey something about it, about what's going on. Yes.
To visualize about the thing.
To be sure about.
Visualize.
To visualize something. To visualize something. Okay. Okay. Yes.
If we just had like all this data and correlations, we would know just about that thing. We might even be able to predict just that one phenomenon. But if we had if we have a model, then we can apply it to a variety of different situations, and we can find a variety of new phenomena which we had not observed.
So what he said about prediction, try to go forward. Yes.
I think if we have a model of whatever we are looking at, then we can use the model to exploit what we are trying to understand and use it to our benefit.
Again, more of prediction and trying to basically
use it in engineering.
Use it in engineering. Okay. Okay. Fine. Yes.
If you have a model, like it represents your idea, so like it validates your idea first of all, and it like reaches out to more.
So having a model validates your idea. Is that really correct?
Yeah.
It's just a model. It's just it. So no model will deliver your pizza, as I always say. No model will deliver your pizza. Right? It will have its limitations, but whether it validates or not, we have to think about it. Let's think about it, because, or in other words, let me rephrase what you're saying. If you are able to predict using that model, you will be able to get some useful information. In fact, there's a very famous saying by some scientist, I forget who it is, but he says like, all models are wrong, but some are more useful than others. Okay, so like that. So anyway, just some, I'm probably going a little bit too much into philosophy, but we'll go forward. So the point is, a scientist that's the role of the scientist. But an engineer is to actually to create solutions for society. Okay, to create actual solutions for society, societal problems. So using these scientific explanations. So by the way, it turns out that actually the scientific process is not so important for engineering. People can tinker around, just try this, try this, try this. You will get some intuition. You may not be able to explain to anybody else, but still you might come up with a very nice product. After all, we know buildings that have been lasting for 5,000 years. I'm not sure if they really had detailed beam bending formulas or whatever, right? But still things were lasting many thousands of years. So what I'm trying to say is, there is an aspect of, leaving out the scientific process, just tinkering and getting solutions. Okay, it is possible. But if you go ahead and use the scientific knowledge that you're building up, use that as a fundamental grounding. I think what some people from some friends already mentioned, you'll be able to optimize the solution a bit better. You'll make it cheaper. You'll make it more efficient. That is the goal. So science does all the foundations, lays the foundations. The engineer will use these, and that's the true engineer, will use this and create solutions. You can also, without learning any science, you can still tinker. And I'm sure if I asked you, hey, you know what, 5 of you get together and build a regenerative braking for my bicycle. So I ride my bicycle to work every day. So I want to press the brake. I want you to store the energy. When I release it, I want to use that energy to go forward. I ask you that. With learning no engineering, no physics, nothing, I'm sure you can sit down, put together some spring, something you'll get something. I'm not denying it. Okay. But the point is, if you want to really make it lighter weight, less costly, more efficient, and so on, you will need to bring these principles up. Okay. So, but that said, you first have to identify the need, and we're going to spend a few minutes talking about it today. Identify the societal need. So by the way, how are we doing on time? I tend to get caught up 12:05. Huh? So we have 10 more minutes, and then we will continue in the afternoon session. Okay. So we have to identify this need, and that process is also non-trivial. It's not that easy. We'll have you do something. And we have to develop the products and processes to satisfy, to come up with a solution that satisfies these societal needs. And constraints is a big pain, but those are the ones that make engineering exciting. You will have constraints for everything. There are no free lunches. Okay? So everything you do, there will be a big pain. Yes, question. Good, I'm glad. In the middle, you have to stop me and say, like, hey, there's a free lunch right now. Should ask me. Huh? Yeah.
So I'm a little hesitant to do this, but sir, what you just said is complete bullshit.
Excellent. Good. No, see, I know it's a little bit rude sentence, but see, I actually encourage people. You don't have to be rude to your teacher afterwards. Please don't quote Professor Srikanth said this and then go and get me in trouble afterwards. But the point, I hope you understand the underlying point that I'm trying to make. The way you listen should have this tinge of suspicion with what you're saying. It's okay. So please take it up to heart. I mean, it's a very valuable thing. It will help you understand things much better. Yes, please go ahead.
So I think you don't necessarily need to identify a societal need in order to come up with a good product. I think you can come up with a product and then you can find applications for it later on. Like the iPhone, for example. You couldn't have predicted, the thousands of apps that would have come up. That isn't a need that you would have created at the start. But at the same time, after you created the iPhone, a few years down the line, needs came up. So I think that would be a different way of looking at this whole process of creating design.
Okay, very good question. And this is a discussion that we do have every time we present this. So his question was, there seem to be some solutions which did not even seem to address a problem beforehand, like the iPhone, right? It seems like a solution that people went crazy about afterwards, but it did not identify a problem, right? So to answer that, I mean, I say that even there was some understanding of some problem. It might be a vehicle to a different each time you come up with a solution, you might spawn more problems which you did not see in the beginning. But if you did not even have the initial seedling of a problem, it wouldn't have caught on, is a counter argument that you can possibly make. Okay, we'll leave it for that. It's a good point. I'm not saying I have a complete answer. Yeah, one question from there.
I don't know. I feel like an iPhone would serve a lot of problems. It's just
no, he's not denying that.
No,
he's saying that you did not see it beforehand. That's all he's saying.
It goes for any product, right? A product with no practicality would never be designed in the first place.
That's the point I was trying to make. So what we are saying is, when the iPhone came up, there was a societal need. Hey, all the phones that are there are not good in some way. They're not that user friendly. They're not so stable, something like that. So let me come up with maybe something which is more expensive, but it has these additional stability advantages. It is integrated in its all its applications. So in their mind, they must have had some idea of some user need. And once it came up, then it spawned more possible problems and more possible solutions. That's my view about it. Okay. So in other words, there is a societal need. There has to be some nucleation, like what he just now said. There has to be some nucleation. Yes.
Sir, a little bit before, I have a problem with that. I think it's complete bullshit. So
good.
Before
so
you
he
said,
didn't even say little bit bullshit. He said complete bullshit. Okay, good.
Yes,
I'm
sir.
glad.
So you said that without any scientific knowledge, you can do some tinkering and you can come up with solutions.
Yes.
Well, I think that you would not be able to do that. So, for example, the braking system, you would need to know how to store. You need to have some idea of how to go about doing it. If you don't have any idea, you just sit with the scale, start drawing on a piece of paper. You will draw a nice house. Then you won't get a braking system. So, if people could solve problems like that without having scientific ideas, like complex problems, without having scientific ideas and explanations and how to apply them, then wouldn't we have created all this technology we had see with us thousands of years ago without having any scientific progress?
Good. So what he's saying is, he's redefining what I said in terms of, hey, If there was a solution, that means there was some science behind it. The fact that you see all these solutions means there was some science behind it. Okay, yeah. And see, and I'm not going to argue completely. So because I'm going to leave certain things hanging out there for you all to make your own decision about what you think is right or wrong. It's okay. That doesn't have to be answered in a closed fashion with the answer at the back of the book. You don't have to flip and say, yes, I got it right. Okay. Some of these questions that we're going to discuss today are going to be like that. Little bit vague. Whatever flavor you want, you can keep it. Yes.
Even if someone does not know the scientific principle and he like tinkers and does something, in the process itself, he might understand there's this process happening and he might try to exploit it. He might not make a universal statement or a formula stating that this will always happen. He might just see that this happens there and he can make it. But it does not mean it will be a sustainable growth of making things, but he might make it.
So, right. So, what we are saying is any person, okay, could come up with some, and that's my point, sort of, right, that you can come up with some solutions, okay, and whether it is science or not, it's actually a little bit vague. So, you come up with a solution, that itself is a process of building some science, or just because it is not generalized to the nth degree, is it not science, is a question. Let's leave it at that. Okay, one last point and then we'll go forward. Yeah. Oh, yeah,
a
go ahead.
lack of scientific method doesn't mean a lack of scientific understanding, right? It just means you don't move with that particular procedure.
So, he's saying lack of scientific method does not mean lack of scientific understanding, and that's your point as well. And what is the next sentence you said?
Just because you don't move with one particular method doesn't mean you won't know what you're doing.
Yeah.
You're just
so, by the way, so see, all of this thing about, understanding is a bit vague in my view. So, I'm not even sure what it means to understand. So, just because I know F is equal to GMM over R squared, have I really understood something? I'm not sure. I feel that goes a bit into the philosophy of things. Let's leave it at that. I can just apply it. You told me how to apply it and then I got the wrong answer. You beat me on the knuckles with my ruler and then I went and tried to get the right answer, right? That's all. So, let's leave it at that. But the point is, let me just explain my point. What we are saying is that there is there is a systematic process and there is a lack of a systematic process. There are two ways you can do it. With the lack of systematic process also, people have hit upon some solutions. Okay, I am actually a proponent of trying to go for a little bit more systematic process because you can make things more efficient, less costly, more long lasting, greater safety and so on. Okay, that's all I am trying to say. But it is possible to come up with some solution even without that, and whether it's got some scientific process behind it or not, let's leave it at that right now. One last point.
Oh, so when you say identifying societal needs, how big of a sample do you take as?
Very good question. How do you really identify a societal need? It's not a trivial thing. It's not a trivial answer. We'll go forward. We'll do some examples and see. Okay. So anyway, so the point here again, going back to the points you all made. So the key element is to combine science, maths and experience to make rational decisions in order to become a better engineer, come up with better engineering products. So rational decisions are those driven by data and logic. So we have to be very clear, and in fact his question is exactly to the point. When I say I have to make a rational decision, rational, have you heard the word rational? What do you think it means? Driven by data, right, I've written it right there. Yeah, so anything else? Any different way of saying the same thing? Yes, thank you. Rational is, you think, a practical way of thinking. What do you mean by that? Can you explain a little?
Not be a very idealistic idea, something that suits the needs of the society, or like it's a viable option rather than thinking out of something that would not really be possible.
I see. But you are talking about the engineering solution, not the, you're not talking about rational decision.
So when you're taking a decision,
I
you
see.
should consider the reality
I
and
see.
what you have, like the resources that you have.
I see.
And how to work with those, rather than you might have a better idea, but do you have the resources for it?
I see. So you are trying to build in practical feasibility into the rational process. Very good point. Any other points? Keeping the constraints in mind. One person who has not participated so far. Yeah.
Rational means reasons. You have to have reasons to back them.
Rational means?
You have to have reasons.
Reasons for why you are doing this. Rational means you have to have reason. Yes.
A decision which makes somewhat sense in, if not all aspects, at some aspects it makes complete sense.
It makes sense, again, like reasons, right? So sense and reason. Okay. So, but the point is, one thing I want to like kind of bring to everybody's notice is that it requires data and logic. Data, it answers the question that he asked earlier. How much data? How many people will you ask? Sometime you have to stop. If you keep collecting data till, like you asked, like, alarm clock, 6 o'clock, you keep collecting data, you will never have time, you will never be able to stop at any point in time and make a explanation. But the fact is you stop somewhere means you are now irrational, because why did you stop now? Why not at least 1 month later, or why not 1 month earlier? That itself is an irrational process. So I want to bring to everybody's attention that really there is no rational way of, there is really nothing like that. It is reasonable, as he said, like something that you can, if somebody asks, I didn't do little, I didn't do too much, I did something reasonable. But that's a very irrational explanation, frankly. Okay, that's how we work. But it's okay, let's embrace it, because, but we have to recognize it. We recognize that, I have to stop somewhere. I'm going to break things. I'm going to take sheets of paper and tear them, find out how much force I require to tear them. Okay, and I come up with an answer, 37.2 newtons or something like that of force. How many experiments am I going to do? I'm going to do 10 million or I'm going to do 2? There's a thing. And then we have to come up with that. We'll come to that also. There's more interesting stuff. Yes. Yes. Oh my God. Let's all hold the table before we fall off. She's come to the conclusion that science itself is not rational, and I agree with that. I agree with that. I'll tell you, it is not rational, man. This word rational is overused, overhyped, nothing. It's okay. There is a scientific method. There is a method. There's a method to the madness. That's all we are saying. There's a method to the madness, but let us not give it great, saying that rational is that. There is a process, and each time you have to be able to explain the process to somebody else. That's all. Good. But the same token, you should not go into the other extreme of not even say, I'm not going to say everything, 2 plus 3 is equal to 7. That's all. I'm not going to tell why. I'm not going to tell why. Like, it should not be like that also. You should try to keep engaging with other people and trying to make, so that it will be useful. At the end of the day, we want to be as useful as possible in various ways.
Sir, what we consider as rational is actually defined by the science and logic. If there's science behind it, if there's logic behind it, it automatically becomes rational.
That's what she's saying, no?
Yes, sir, that's what I'm asking. How?
How? Because see, there's nothing, that sentence like, there is science behind it. That sentence makes no sense. There is a method behind it. A method which I can explain. But is that method itself correct? Why that method? For example, we'll go to this in the afternoon. I want to find out what force it takes to tear a sheet of paper. Okay? How will you do that? We'll come up with a systematic way. We'll take that paper, we'll hold it, we'll put one like jug of water in it, we'll add 100 ml, and slowly we'll find that it will tear. Okay? But then I'm going to ask you a question. What color of shirt was I doing when I was doing that experiment? Did you consider that? No. You think it's not relevant. Why? That itself is irrational. So there's no such thing as science behind it. There's, you have to make a choice about what are all the things. What was my birthday? Was my birthday in even month or an odd month when I did that? When Galileo did the experiment of breaking of beams, was Galileo's birthday on an even month or an odd month? Did you take it into consideration? No. Like that. But how? Why not? Why did you not take into consideration? I feel it is not going to be. It's a feeling, it comes in there. Okay. Let's come to that. There's lots of interesting stuff. I'm glad I'm saying please go while having lunch, discuss this, decide that this prof is bullshitting through like the entire period of this thing. Come back with lots and lots of questions and challenges. Okay, really, it's fun. See, this is all stuff that I want to something that is totally off the left field. Nothing. You should not expect this sort of discussion at all. You would probably expect somebody will come and tell you something about beam bending theory or something like that, right? But here I'm coming and talking all sorts of crap, right? So that's how I want it to be. It should be like very off. So let us stop with the last 1 minute. So there's a systematic process that we'll have to do in order to come up with an innovative design. Okay. So we will continue now. It's time, right? What time is it now? It's there's a clock there, but I'm not sure if it's 12:20. So it's time to stop, right, for lunch. Okay. So we will meet again at 2 o'clock, and then we will continue discussion. Okay. All of you should discuss and come up with some questions that will really stump me, okay, or stump yourselves. Okay, thanks guys, see you.